Alright, so here we've got to find the stationary points again and sketch the curve, and it wants us to use a table, which is a little annoying. So usually if it's easy to find double dash, we won't bother doing a table, but let's practice here. So if I differentiate, I get 15x to the 4 minus 60x squared, and I know for stationary points, that is where my f dash of x equals 0. So let's have a look at that. So 15x squared, if I factorise by 15x squared, I get x squared minus 4 exactly. So where does that equal 0? Well, we know that x would have to be 0 and plus or minus 2 for that to happen. So if I'm looking at a table of values for x, I want minus 2, a 0 and a 2. And then my y dash is going to be 0 for those. So where else am I going to look? I'm going to look at 1 and minus 1 and 3 and minus 3 and just check what my y dash looks like. So remembering my y dash is like actually I might further factorize. So let's look at y dash being, obviously that part's going to be positive, so I can kind of ignore that, positive. And then I've got x minus 2, x plus 2, for example. All right, so if I put a minus 3 in, this is going to be a negative, and minus 3, that's going to be a negative as well, so that's going to be a positive. If I put a negative 1 in, that's going to be a negative, that's going to be a positive, so that's a negative. If I put a 1 in, the first bracket is going to be a negative, second bracket is going to be positive, so negative. If I put a 3 in, I'm going to get a positive and a positive, so that's going to be a positive. So if you think about it, this is what it looks like it's looking like. So positive gradient, so increasing, and then a 0, then a negative gradient, then a 0, then a negative gradient, so decreasing, then a 0, then a positive gradient. So it looks like what we have here are a maximum turning point, a point of inflection, so horizontal point of inflection, and then a minimum turning point there. So I didn't find their y values. I need to find their y values as well. So let's check at minus 2. Let me get rid of that now. What else do I need or not need? I can get rid of, I've got all those, don't I? Yeah, just get rid of that. Alright, so at x equals minus 2, at x equals 0, and at x equals 2, I've got, what did I say? That's maximum. This is a horizontal point of inflection, and this is a minimum. Okay, so if I sub minus 2 in, I might need my calculator. So minus 2 to the power of 5 times 3, and then I should get at that. So I could look at f of x, x cubed 3x squared minus 20. That's probably easier. So minus 2 squared is 4, 4 3s are 12 minus 20, and then I've got the x cubed, so I think I'm going to get 64, but please check in your calculators. When I put 0 in, I see that I'm going to, easy from that one, 0, 0, so I'm going to get 0. And then when I put 2 in, I should be getting the same but negative, so negative 64. Please check those in the calculator. Alright, so I know that is the case, so let's have a bit of a sketch then. Here's my x, here's my y, very bad y. Alright, so let's say minus 264 is, let's put it here. So that's at minus 2, this is minus 64. And remember, this is a maximum turning point, okay? So it's minus 264. Minus 264 is not there. Alright, minus 264 is here, which makes more sense. Alright, so there's our maximum turning point. Get rid of this one. Silly, silly. Alright, and we've also got 0, 0 as our point of inflection, and we've also got 2 minus 64. So there we go, and that's our minimum turning point. It's going like that. So you can see that. So we're going from an unhappy curve to here, and then it changes point of inflection, so concavity changes to a happy curve here. Oops, it was a horizontal point of inflection, so let me fix that up. So it's going to go like this, and it's going to horizontally out, and then go like that. So it's going to look like a bit of a cubic there in order to have that horizontal point, which I missed, a point of inflection, not just a point of inflection. The first way, the purple way, was just if it was a point of inflection, but here, because it's a stationary point as well, it's a horizontal point of inflection.